Welcome everyone. Today we are starting electromagnetic waves. But before I start, there is an announcement that I'm running GCSE crash course batches. Well, it's a very less time remaining, but still you can join and definitely can ease the exam. As well as I'm running the doubt sessions. That means if you have specific doubts, you can just enroll yourself for one or two class or according to your doubts. For the new sessions from year 1 to 13, if you need any subjects, I have tutors for all the subjects. So all you need to do is just email us at exactacademy@gmail.com and we'll coordinate accordingly. So let me start with electromagnetic waves. Electromagnetic waves, as the name suggests, are the kind of waves that are produced by the oscillation of electrical and magnetic field. It happens when these fields are at right angle, and then the wave that is produced is also in a right angle. So ultimately they all are perpendicular to each other. Now look at this diagram. In this diagram, you can see the z-axis is representing the magnetic field, that is the blue one. So magnetic field has its own direction and electric field is y. Definitely all the axes are perpendicular to each other. X, y, z are all perpendicular. So in the direction of y, the pink one that you can see are the electric field. So direction of electric field is in this and direction of magnetic field is in this. Definitely they are making a 90 degrees. So the wave that is produced is perpendicular to both of them. That means this direction, the x direction, represents the direction of magnetic wave. So the magnetic wave, electromagnetic wave that is produced, it's because of the oscillation of these two fields when they are perpendicular to each other. This gives birth to an electromagnetic wave which is perpendicular to both. Clearly z axis is perpendicular to y and z. So let me write down the definition, and specifically the definition that you have to write in exam is the wave produced because of the oscillating electric and magnetic field when they are perpendicular to each other. Well, electromagnetic waves are of 7 different types, and when these waves are arranged according to their wavelength or the frequency, they together called electromagnetic spectrum. Now this is electromagnetic spectrum. It means the combination of all 7 electromagnetic waves, and they are arranged according to their wavelength, or you can say frequency. Starting from the first one, this is radio wave, which has the highest wavelength. So now you can understand how they are arranged in terms of wavelengths. They are arranged in a decreasing order of a wavelength. So they are arranging as per like the decreasing order of wavelength, and radio waves have the highest wavelength. If you go downwards, that means towards microwaves, infrared, visible, ultraviolet, x-rays and gamma rays, the wavelength keeps on decreasing, and the value you can clearly see as well. So it keeps on decreasing, and finally at the very end, which is a gamma ray, has the smallest or the shortest wavelength. We have studied the equation which was wave speed is equals to frequency into wavelength. From here, if speed is same, because for all electromagnetic waves, their speed in vacuum is same, which is 3 into 10 to the power of 8 meters per second, that we have been studying so far for light, that this is the speed of light. So it's actually the speed of all electromagnetic waves. If speed remains same, that means now speed will be constant. So constant, say for example, I'll denote this constant as c, frequency into wavelength. Let me represent with lambda. This is a notation of representing wavelength. So I can say frequency is equals to c over lambda, or frequency is inversely proportional to lambda. If something is constant, we can directly convert into proportionality. Simply frequency is inversely proportional to wavelength. It means the one which has the highest wavelength will have the lowest frequency, and one which has the lowest wavelength will have the highest frequency. This radio wave has the highest wavelength, that means it will have the lowest frequency. So in terms of frequency, it is arranged as increasing order of the frequency. So as you keep on moving in, downward direction, the frequency keeps on increasing. And for the gamma rays, that's why they are very dangerous. They have the highest frequency. Now this is about the basic electromagnetic spectrum. Let me discuss about the properties of all electromagnetic waves, not each and every property. As of now, we are describing the common property that all electromagnetic waves share. So the two common properties of electromagnetic waves are they all are transverse in nature. We have studied when I was explaining in waves. What are transverse waves? The transverse waves are the waves in which the particles move up and down, and basically the direction of particle is perpendicular to the direction of the wave motion. So such kind of waves are transverse, and all the electromagnetic waves, they all are transverse in nature. And I just described that they have the same speed in vacuum, which is 3 into 10 to the power of 8 meters per second. So like not necessarily only in vacuum, you can say vacuum or air, there will be not much difference. So these are two most common properties that they all share. But there are so many properties that are pretty much different from each other, and that's why their application are also different, because they have the different wavelength, different frequency. Now let me see the property of each and every wave. First wave that we will be discussing is the radio waves, because in electromagnetic spectrum you have seen that there are radio waves which are at the top. They have the highest wavelength. If they have the highest wavelength, the longest wavelength, that means they can travel a longer distance. When we draw it here like this and this is the distance covered by a wave in its first cycle, because this whole is a cycle and then it keeps on repeating itself. So that's the one cycle. So the total distance covered in this is your wavelength. Or if I say the distance between two consecutive peaks or consecutive troughs, they are actually same. If I join it, it's a parallelogram, right? This will be a parallelogram. So obviously, whether I'm talking about the distance covered by a wave in its first cycle or distance between two consecutive peaks, the both distance are same, which is actually wavelength. So you can define it in either way. So since that distance covered in one cycle is longer than comparatively to the other waves, it can travel a more distance without a doubt. So these waves are, first of all, the important things can be easily generated, because if you're sending any signal, any electromagnetic wave, you have to produce that electromagnetic wave. So you basically, it's very easy to generate those electric waves, and then with the help of electricity you can generate those waves, and then these waves can travel a very long distance because they have the longer wavelength. These waves are in omnidirectional, that means they can travel in all the directions wherever you want, and this is the reason they are used for satellite communication and broadcasting, because ultimately you want these waves to reach at different parts. You want these that so that it can reach to the person sitting in London, as well as the person who's sitting in India, and everywhere basically. So as they can travel in all the directions, they are ideal for uh, broadcasting or that telecommunication. Second is why they are widely used for communication, because they can penetrate through the walls very easily as well. So say for example, if you are using a mobile cell phone and in a very closed room, still you will get the network, because they can pass through it easily. So you need not to worry on that part. So these all things are basically will make this an ideal wave for the communication. So I'm just writing down the answer. So here you can see, if in the exam they will ask you why radio waves are ideal for the radio, television, broadcasting, or in mobile communication, because they possess three properties. They can travel a longer distance, they can penetrate through the walls, and they can travel in all the directions. For exam point of view, you can write these 3 points, but you can add if you want that the different frequencies, because the radio waves doesn't have a one frequency, they have a range of frequencies. So if I talk about the long waves of radio waves, they can diffract through the mountains. It means when they reaches to the mountain, they just travel or defects around it. It just cover it and get past through it. I mean, it will not be absorbed by the mountains, because ultimately when you are sending a signal, you want that signal to reach to the other side, obviously. And if there are mountains and peaks in between it, and what if they absorb it? It doesn't happen like that. Diffraction is when the light bend around the obstacles, so it actually bent around that mountain. So this is one of the important thing that we can use radio waves for communication. Or you can say, if the shorter waves of the radio waves, they can reflect from the ionosphere and return back to the earth, so that will be also helpful, and that we will be discussing in our next segment. That is where I'll be discussing the transmission thing, how the radio waves are produced and how they reach to the different parts. This diagram will give you an idea that how radio waves are generated artificially or by men. Here it's a transmitter and here it's a receiver. So what happens is, radio waves are generated artificially by the transmitters and received by the antennas or the radio receivers. How they are generated? It's simple. They are generated by, you don't need to go too much into deeper because it's not in your syllabus. All you need to know is they are produced or generated by the charged particles when these charged particles accelerates. And how? With the help of a transmitter, they are produced in a transmitter with the accelerating charge, and then being transferred to the receiver through you can say by antennas, right? It says transmitter here, and it received by the antennas here as well, and in between the radio waves are being sent and it travels. So let me write down the answer. Like, if the question they will ask you that how they are produced, so you can answer like this. So this is the answer. You're supposed to write down the 2 points, that they are produced by accelerating charged particle and being sent by the transmitter and received by the receiver. See how exactly the radio wave works. As of now, I'm just only looking, just forget about the satellite phone that I have drawn. Only look into the radio receiver, the tower. That means we are talking about how the radio waves work. This is your radio and this is the tower. So suppose that means this is the basic radio station from where it's being broadcasted. So the signal, the radio waves are generated with the help of the microphone. Like through microphones the oscillations happen, and ultimately the radio waves are generated. The radio waves are sent. There are two different types of radio waves. It's AM and it's FM. The FM signals are comparatively weaker and they gets reflected through the surface of the earth. This is earth's surface, and these waves reaches the earth's surface and gets reflected, ultimately reaches to your radio station or main radio, basically. Sorry, not radio station, radio. Then the second signal, which is AM, the stronger one, it gets reflected from the ionosphere. It goes up there and gets reflected by the ionosphere and reaches to the radios. So ultimately, both the types of signals are sent. They get reflected by the two different mediums, one by the earth's surface and another by the ionosphere, and ultimately after the reflection reaches to the radio, and the receiver will be able to hear what is being telecasted or broadcasted. This is how the radio wave works. This is comparatively, as compared to the satellite phone, this is comparatively a weaker radio wave being sent, a lower frequency radio wave being sent. If I talk about the working of a satellite phone, it's not the cell phone I'm talking about the satellite phone. There is a basic difference, because satellite phones transmit signals via the satellites, whereas the cell phones that you are using, they don't use satellite at all. Instead, they use the towers that are installed on the land. So they use the land based towers. So this I'm talking about because here the pure radio waves are used for the satellite communication. This tower basically sends the signal, sends the radio waves, and then it's received by the satellite. And then after this one, The signal from the device is being transmitted directly to the nearest satellite, and then this satellite which then send the signal to the nearest land based center. Here in this case this is the land based sender. So what's happening here, the satellite phone is sending the signal to the satellite, and then satellite sends the information to the land based tower, and then this transmits the signal to the receiving phone, wherever be the receiving phone. So these two receives the radio waves, and in this way this is how it works. If I talk about the cell phones, that we will be talking about when we will study the microwaves, which is the next wave. So let me move on to the microwaves. The next type of wave is a microwave, which has a more frequency as compared to radio waves, but a shorter wavelength if you're gonna compare it with the radio waves. But still, these waves are used for the telecommunication, that means for your mobile communication, as well as it's used for heating as well, that your microwaves ovens, they are using microwaves. So they are definitely a form of electromagnetic waves, and as compared to the radio waves, the microwaves are easier to focus. And we talk about its use in the technology. Microwaves are also used for the telecommunication, the satellite communication, just like the radio waves. But if I talk about the preference, in satellite communication, the microwaves are more preferred because they can easily penetrate through the Earth's atmosphere. Because many radio waves you have seen that they get reflected by the ionosphere, so you have to increase their frequencies. So sometimes you are using my radio frequency microwaves or higher range frequency microwaves, which are even comparatively harmful as well. So why? Because for satellite communication they have to penetrate through the atmosphere, so a little more frequency waves are required, but at the same time should have a higher wavelength. So that's why the microwaves are more preferable in satellite communications. So we have already seen how the satellite communications happens. Now let me see how the mobile communication, mobile phone communication takes place. Now see the working, how exactly it happens. So basically the signals from the cell phone is given off as soon as you make a call, send any message, or even turn on your mobile. The code or the message being sent to the nearest base station, and then these signals by the fiber optics, here either by the wire or the fiber optics, is sent to the wireless access point. Then these wireless access points sends the signal to the wired backhaul, and which then given to the base station, the nearest base station of the receiver phone, and ultimately the waves are sent to the receiver phone, and this is how its whole thing gets completed. This is the working of the microwaves. The other working of microwave is in microwave oven. So let me see its working. In a microwave oven, there is a device called magnetron, which produces the microwaves. Now you can see in this picture that different microwaves are being reflected. So what basically happens, that microwaves gets reflected of the metal, that is like interior is made up of the metal, in order to, so that the microwaves can be reflected and all can be focused to the food. Then what happens, that the more, because every food has a water molecule inside it, so the main work of these microwaves is to give off energy to the water molecules. Then these water molecules starts to vibrate, which results in the friction between each molecules, and they get heated up, and this is the reason how the food gets heated ultimately in a microwave oven. This is the working. So microwave ovens are used to heat the food, whereas microwaves in communication is used by the cell phones. So let me write down the answer for the microwaves. That they are used to send signals to satellites in a satellite communication. They are used in cell phone communication. They are shorter waves than radio waves but have more frequency. They are more focused. They can even penetrate through the atmosphere, and these waves are used in microwave ovens for cooking food. So basically that's it for today. We have done two types of electromagnetic waves, and still five more electromagnetic waves are remaining, and that we will be doing in the next class. But before that, there is an announcement that if you want, like I do this in my every video, so if you want to enroll yourself for any new batches, so just email us at exact@gmail.com. And also if you want to access these worksheets, just log into It's totally free. So either you can go for Android app, which is in the name of XI, available on Play Store, or you can log into our website, which is www.xiacademy.com, and you can avail the worksheets as well as the free notes. So that's it for today. Have a great day. Bye everyone.